Okay guys, the lesson today is to be able to analyze and sketch graphs. Sometimes these graphs can tell stories, just by looking at the data contained within the graph. All right, so the essential question today, how can you use a graph to represent relationships between quantities without using numbers? All right, let's take a look at this first graph. All right, it says, first of all, we have a horizontal axis of time, we have a vertical axis of water level, right? And the graph obviously shows the change in water level over time. Question A says, how is this graph different from the other graphs you've studied? Well, obviously it's not a straight line, right? And it's not a curved line, all right? We have different sections, that are linear. And each of those sections tells a story. Write a short paragraph that describes how the water level changes over time. What situation can this graph represent? Right? Now, you can use your imagination if we're talking about changing water levels over time, whether we're talking about a lake or a pool. I'm going to use the example of a pool. Right? So if we open up a pool, or if we store a pool over the winter, right, the water level's at a very low level, right? You don't totally empty the pool because you don't want the walls to collapse, but you have some water in the pool to keep those walls up straight, but not quite full if we're talking about an above ground pool. And then all of a sudden, as time passes, right, winter's over, right, now we increase the water level in that pool, right, and that's why we see this line going up from left to right. The water level increases. Then the pool reaches the capacity, right, so over the summer days, the water level stays the same, and that's what we see here, right, the water level staying the same. And then as the season ends, right, we empty water out of the pool and we get back down to a level that we store, right? Not totally empty because this line doesn't touch zero, so it's not totally empty, but it obviously decreases to the water level that it started with. So that's just an example of how this graph can tell a story. You just have to use your imagination a bit. Right? But what we're using is the relationship between the horizontal axis and the vertical axis, horizontal being time, vertical being water level, and then what the slopes of these lines and directions of these lines can tell based on the relationships. All right, next example. You're asked to work with a partner. You're riding your bike. Match each situation with the appropriate graph and explain your reasoning. All right, so I just got to back this out a bit, zoom this out so I can see everything here. So we have different graphs. All the graphs have a horizontal axis of time, and all of the graphs have a vertical axis of speed. Choice A says you gradually increase your speed. Then you ride at a constant speed along a bike path. Then you slow down until you reach your friend's house. All right, and at your friend's house, you'd want to stop. So let's see which one of the graphs that would work with. All right, so we gradually increase our speed. So that means our speed has to be go from 0 and it increases. So that eliminates choice B here, right? Because speed has to gradually increase. So we're looking at these three graphs here. Then the next sentence says, then you ride at a constant speed. And that would have to be this graph here because we gradually increase the speed here, and then we ride at a constant speed, and then we slow down when we reach our friend's house. So if we're looking at choice A would have to match up with choice C. All right, A and C would be matched together. All right, let's take a look at choice B, or answer B. You gradually increase your speed, then you go down a hill. All right, then you quickly come to a stop at an intersection. All right, well, if we gradually increase our speed, right, that once again eliminates choice B because it's got to be one of these two. But then we go down a hill, and this is one of the misconceptions that students have when they read these graphs, because when you go down a hill, you would think that, okay, the slope would be negative, but no, when you go down a hill, your speed actually increases when you go down a hill. Right? When you go down a hill, you're going to have an increase in speed over a short period of time. So when you're looking at these graphs and you're going down a hill, the line actually jumps up quickly from left to right, and then you eventually, what does it say, come to a stop. So you're going from a very high speed, and then quickly you come to a stop because you reach an intersection. So choice B has to go with, right, graph A. Let's look at answer or choice C. You gradually increase your speed, then you stop at a store for a couple of minutes, then you continue to ride, gradually increasing your speed. Well, obviously that would have to be graph D, because once again you're gradually increasing your speed. Then you come to a stop that's here, right? And now you're stopped for some period of time, because now your speed is 0 and time still continues as it goes from left to right, but your speed is 0. And then it says that you start gradually increasing your speed again, so choice C, right, would have to go with graph D. Then obviously that would mean choice D goes with graph B, but let's read it anyway. You ride at a constant speed, all right? So here's your constant speed part of your graph. Then it says you go up a hill. Now think about that, right? Once again, students want to think when they go up a hill, the line's going to go up from left to right, but no. When you go up a hill, that means that you are slowing down your speed, right? When you go up a hill, it's harder to pedal, so your speed actually decreases over time when you go up a hill. So you're going to see your line go down from left to right when you're reading these graphs. And then once at the top of the hill, you gradually increase your speed again, right? So that would have to be graph D. So when you're reading these graphs, be very careful about going uphill and going downhill, right? When we're going downhill, your line actually juts up like it does here in this graph A, because when you're going downhill, your speed increases so over time. When you're going uphill, your line actually goes down from left to right, because when you're going uphill, your speed actually decreases. All right? Okay. Next activity says work with a partner, then graph. The graphs represent the speeds of two cars. One car is approaching a stop sign, the other is approaching a yield sign. Now, you guys are 7th graders, so you're non-driver, so it's a little difficult to understand the difference between a stop sign and a yield sign. And to be honest with you, some adults don't know the difference either between a stop and a yield. A yield means you don't have to come to a complete stop unless there's traffic, but a yield sign means you slow down. Whereas a stop sign, no matter if there's traffic or not, you have to come to a complete stop. And that's your difference here. So if you're looking at these two graphs here, how are the graphs similar? How are they different? And explain. Well, they're similar because they start at the same speed, right? So both cars are starting at the same speed. But then one car gradually slows down, right? We quickly slow down, but we don't come to a complete stop, because notice that your speed is not 0, right? If your line, if the blue line touches your horizontal axis, then your speed is 0. But your speed's never 0. So this would have to be the example of the yield, right? What is yield? Y, I, E. I before E except after C Pallotta, right? So this is your yield, Y, I, E, L, D. And then this would be your stop, right? Because this car comes to a complete stop. So that would be an example of your stop sign. So if you're comparing the steepness of the graphs, right, this one is steeper because you're slowing down quicker here. Here you come to a gradual stop. Here you're slowing down quickly, but you don't come to a complete stop. All right. So answer, or question C we've answered. Which do you think represents the car going to a complete stop as opposed to the yield sign? All right. Then we have this next example. Graphs can show relationships between quantities without using specific numbers. And that's what we've been looking at here, right? We see that when the line rises from left to right, we show something is increasing, right? We see that over time, the distance is increasing. Here, right, no change, right? The change is constant. And then we see that distance is decreasing over time. So your line goes down from left to right. So when you're reading these graphs, you really have to pay attention to what these slopes mean. A positive slope means something is increasing, and in this case, it's increasing distance in relation to time. This horizontal line means that there's no change in distance over time, but it's not a distance of 0, right? Because you are some distance from 0, but that distance is staying constant. And then you have your negative slope, or line going down from left to right, means that your distance is decreasing and approaching 0 and eventually getting to 0 at this point. All right? Now, you guys could go ahead and try these graphs on your own, but that's essentially, what this lesson is about. Just being able to analyze the relationships between the horizontal axis and the vertical axis, and trying to create some sense or a story, based on the horizontal axis and the vertical axis and what the slopes of those lines mean. All right, so that's just a real quick lesson or review of what this lesson would be about. You could try those on your own, and I hope that that was helpful. All right, take care.